Hello, welcome to Z Talk. From this session, I'd like to kick off another series about Kafka. The reason to start this topic is that I've seen environments where people set up Kafka without monitoring. Or there are tons of metrics out there available, but what are the key metrics to indicate the health of your Kafka environment or the performance of your application? Either of which is a big problem. Like when there are issues going on Kafka, and you are in the process of troubleshooting, it will be extremely difficult to check your cluster if there's no good metrics visibility. And besides monitoring, people sometimes also don't realize the variety and complexity of operations to perform on Kafka, like adding brokers, upgrading Kafka, moving partitions, and changing configurations. From performance point of view, in most cases, we need to tune Kafka to improve the performance of our applications overall, right? So with these backgrounds, I think it's worth to have a deep understanding of Kafka. That's why I plan to talk from basics like Kafka CLI to like a little more advanced topics like Kafka cluster operations. And I also like to discuss about Kafka monitoring specifically. Sounds good? Cool. For this session, let's start from basics. I'm going to go through some key concepts and features of Kafka, and then let's play with Kafka CLI a little bit to understand how do we create topic. Once we have topic, like how do we produce messages to that topic, and how do we consume those messages that we produce. All right, that's the plan. First thing first, what is Kafka and what are the use cases? Well, in the early stage of companies, I'll say normally their application or system is relatively simple, like the chart shows. Probably the application only involves one source system, which creates data and feeds data to downstream. In this case, that's also assume there's only one target system involved, right? In that scenario, it's quite straightforward. There's nothing much to worry about. However, after a while, with the expansion of business, more systems or applications are getting added to the picture, and things started getting complex. Because there are multiple sources and destinations, which require a lot of integration of data due to dependencies of each pieces, like the chart shows. Soon, you will find out, it's out of control. For example, let's say if you have 6 source systems and another 6 target systems, if that's the case, you'll have to create 36 integrations in total. And you also have to take into account that each integration comes with various challenges. For example, how do we deal with data transfer, right? And how do we deal with different data formats between applications? And what else? We also have to consider an increased load from the connections for each source systems, right? Big headache. With those challenges, we need a good solution. That's where Kafka comes into the picture. Kafka is a high throughput distributed messaging solution and is decoupling of data streams and systems. It was created by LinkedIn, and now it's an open source project mainly maintained by Confluent. Kafka has distributed resilient architecture, fault tolerant, and it's high performance. It provides real-time latency scale less than 10 milliseconds. And what's more, Kafka is scalable horizontally. You can scale up to over hundreds of brokers uh, for your Kafka cluster. Well, some use cases. I just list out some use cases right here, like messaging system, activity tracking. I'll give you some real world example of use cases. Like let's say Netflix. Netflix uses Kafka to apply recommendations in real time while you're watching movies. Uber. Uber uses Kafka to gather users, taxis, and trip data in real time, to compute and forecast demand and compute surge price in real time. LinkedIn uses Kafka to prevent spam, collect user interactions to make better connection recommendations in real time. Those are really, common or like good use cases of Kafka. All right, I guess it's time to dig into Kafka. So in the next couple of slides, let me walk you through some key Kafka terminologies and also Kafka infrastructure. All right. Let's start with topics, partitions, and offsets. What are they? A topic, it's a particular stream of data. It's kind of similar to a table in a database, just without all those constraints for a table. Like you have to have a schema for a table, right? But for Kafka data topics, you don't have to have those constraints at all. And you can have as many topics as you want in your Kafka cluster. Each topic has a unique name that it can be identified by its name, right? And inside of topics, topic is split into partitions. Each partition is ordered, and each message within a partition gets an incremental ID, which is called offset. I shared an example here in the middle of the slide. I guess it helps you understand better the structure of Kafka topic. You can see for this specific Kafka topic, it contains 3 partitions, right? So follow this example, some key takeaways. So firstly, offsets only has a meaning for a specific partition, and order is only guaranteed within a partition. Remember, this is really important. Order is only guaranteed within a partition, not across partitions, right? So if you look at this example, which kind of makes sense, right? So when you are trying to locate your message that is stored in this Kafka topic, you have to tell the offset along with the partition. Otherwise, you see there are 3 partitions out there, and each partition has an offset ID called number 3, let's say, right? So if without knowing partition, just knowing offset, you still can locate your message, right? And data is kept only for a limited time. If I remember correctly, the default is 1 week, but is totally customizable based on our requirements. Once data is written to a partition, you can't change it anymore. Remember, Kafka is a mutable system, right? And data is assigned randomly to a partition unless a key is provided. This is another key feature of Kafka. So I will explain it more shortly, and also I'm going to show you what I'm talking about this feature in my demo. Cool. Next, let's jump to brokers. A Kafka cluster is composed of multiple brokers, or servers, I can say here. Each broker contains certain partitions of a topic. Kafka balances the load of the brokers in the cluster and distributes the partitions to the brokers automatically for us. And each broker is also called a bootstrap server, like I mentioned, which basically means you will be connected to the entire Kafka cluster once you connect it to one single broker. It could be anyone in the cluster. Aside from broker, we also need to set up replication factors for topics. And normally 3 replicas per topic is the golden standard. The replicas of a partition are being distributed to different brokers so that if one broker is broken down for any reason, another broker can quickly pick up and continue to serve the data. Something important to note here, just remember at any given time, only one broker can be the leader for a given partition, and only that leader can receive and serve data for a data partition. The rest of brokers will just synchronize the data. It's kind of similar like the logging mechanism for database clusters, right? Only one master node handles the writes, and the rest of the nodes just handle reads, right? It's kind of the same concept. Therefore, each partition has only one leader and multiple SRs, which is a short for in-sync replicas. All right, let's jump to the next, which is producers. Apparently, producers write data to topics, and producers automatically know to which broker and partition to write data to, which is one of the cool capabilities that Kafka provides, right? And in case of broker failure, producers are able to recover out of failure automatically. There are options that producers can choose to receive acknowledgement of data rights. There are 3 options out there: x0 equals 0, equal 1, and equal all. Basically, the difference is there could be a possible data loss to no data loss guarantee. Like if you choose x equals 0, basically that means producer will not wait for acknowledgement at all. Definitely that could possibly cause data loss, right? The second option, x equal 1, which is the default option. 1 means producer will wait for leader acknowledgement only. That kind of limited the data loss possibilities, but it still could happen. Like you only acknowledge the right on leader, but after the acknowledgement, let's say if something goes wrong with leader broker, the broker is down, it moved to another broker, and for some reason the data was lost on that broker, you still got data loss, right? That's why there's the third options for your consideration, which is x equal all. That basically producers make sure all leaders plus all replicas acknowledgements, which basically guarantees no data loss at all, right? Producers can choose to send a key with the message. This is one of the most important feature of Kafka. I mentioned this like in my earlier slide. I just brought it up again. So basically, if a key is sent, then all messages for that key will always go to the same partition. Otherwise, if key equals to null, data is sent like round robin from broker 1, broker 2 to broker 3, something like that. All right. A good use case here, let's say we're using Kafka to track the real-time location of trucks, and there are a number of trucks we want to track. Because there is no data correlation between trucks, the data for different trucks is totally okay to be stored at a random partition, right? However, for a specific truck, the data is time sensitive, so that we have to make sure Kafka stores the data in exactly same order when they receive it. Otherwise, the tracking is not going to work, right? We will have to use a key with the data so that the data for that specific truck always go to the same partition. Remember, again, the order of the message is only guaranteed at partition level, not across partitions. Right? Cool. That's pretty much for producers. Let's jump to the last one, consumers. Consumers read data from a topic, and similar like producers, consumers also know which broker and partition to read data from without any user's instructions. All right. When we talk about consumers, we have to talk about consumer groups and consumer offsets as well, because consumers have to read data in consumer groups, and each consumer within a group reads from exclusive partitions. These two items is quite important to remember. Take a look at the example right here in the bottom of the slides. Here there are multiple consumer groups, and inside of each group there are multiple consumers, right? And remember here, each consumer within a group reads from exclusive partitions up here. So due to these constraints, let's say if you have more consumers than partitions, some consumers will be inactive, right? And Kafka stores the offsets at which a consumer group has been reading, so that if a consumer dies, it will be able to read back from where it left off real quick. That's basically what consumer offsets all about. All right? And consumers, we have to choose when to commit offsets. That comes to another important configuration. It's called delivery semantics for consumers. There are three delivery semantics: at most ones, at least ones, exactly ones. I believe the first two are the most popular ones to consider. So I'll explain a little bit in detail. So the first one, at most ones, basically that means offsets are committed as soon as the message is received. The downside of this option is that if the processing goes wrong for any reason, the message will be lost because it won't be read again, right? On the other hand, the second option, at least ones, which is usually preferred because offsets are committed after the message is processed. And if the processing for any reason goes wrong, the message will be read again. Basically, this way, it prevented message being lost, right? But the downside for this option is that this could result in duplicated processing of messages, because every time the processing goes wrong, the message will be read again. Definitely it's going to cause duplicates, right? Next, let's talk about broker discovery. Actually, we've already covered it in the previous slides. I just gonna talk it one more time because it's also important. So every Kafka broker is called Bootstrap server. So that it means each broker knows about all brokers, topics, and partitions via metadata. And you only need to connect to one broker, and Kafka client will route your data to the appropriate brokers and partitions for you once you provide the topic name that you want to write data to. All right. Zookeeper. Zookeeper is just like the manager of the Kafka cluster. Um, Here I list out a couple of key takeaways for Zookeeper, like Zookeeper manages brokers, and Zookeeper helps in performing leader election for petitions. Remember, we talked about it. For any given petitions, there should be only one leader, right, at any given time, and only that leader is able to serve the data. The rest just sync the data, right? Zookeeper also sends notifications to Kafka in case of changes, like there's a new topic being created, broker dies and broker comes up, and there are topics being deleted. All of those changes, Zookeeper sends notifications so everybody in the cluster knows. All right, and Zookeeper by design operates with an odd number of servers because Zookeeper has the leader which handles writes, and the rest of the servers are followers which handles reads. This is also can similar like the database cluster mechanism. Leaders, only leader or master handles write, and the rest handles read only, right? I think that's basic. That's the reason. By design, Zookeeper operates with odd number of servers because Zookeeper has to elect a leader. If the number of servers are even, it's gonna have some challenges to elect the leader sometimes, right? Cool. All right. Finally, summary. So sorry, the today's PPT is quite long, but is necessary because we have to remember or talk about those key features in order to get better understanding of Kafka, right? Some key takeaways here. Messages are appended to a topic partition in the order they are sent. Basically, that's what Kafka guarantees, right? And consumer read messages in the order stored in a topic partition. As long as the number of partitions remain constant for a topic, the same key always goes to the same partition, right? And the benefit of having a replication factor of 3, I mentioned previously, 3 replicas per topic is the golden standard. Why? Because with 3 replicas, it allows for one broker to be taken down for maintenance and another to be taken down unexpectedly. That's why 3 replicas is the golden standard. All right, cool. That's pretty much the concepts I want to cover, and now I guess it's time to jump to our demo. So in this demo, I'm gonna firstly walk you through a Kafka CLI. So so that I can show you or verify those key concepts I just mentioned again. So let's verify in the lab in the CLI to see what I'm talking about. All right, cool. Remember to sum up and subscribe my channel if you think this session is good, and again, leave comments if you have any questions. Right? Cool. Let's do it. All right. Am I the download page of Kafka? But first thing first, you will have to install Java JDK if you haven't done so on your laptop, because Kafka is going to run on top of Java. All right. So switch to my terminal. Just issue with Java. As you can see, I've installed JDK 1.8. But for your case, if you plan to test out the latest version of Kafka, which is v3, you better install higher version of Java JDK, because notice right here, the deprecation of support for Java 8. All right. Once Java JDK is installed, you're going to install Kafka. There are different options. Like if you're using Linux system, you can install Kafka via package manager, or you can just download the binary and install on your own. If we're using macOS, of course, you can install Kafka via Homebrew. Homebrew gonna take care of everything. That's exactly what I did. Like brew list grab Kafka. See, it was already installed. So once it's installed, verification is quite simple. Just type Kafka and hit tab. If everything works as expected, you should be able to see it's automatically list out all the Kafka CLI commands available for you. All right, something like this. All right, that's pretty much the setup. So how about create a topic real quick to kick off our demo? Before we can create a topic, we firstly need to start Zookeeper and Kafka service. So if you install Kafka via Homebrew, you can start them as the service, like brew service list. As you can see right here, there were two services out there, one for Kafka, the other for Zookeeper. You can start them one by one. All right. And if you install via binary on your own, you can start these two components from command line. So I'll show you how to do that. Basically, you just need the configuration file with the startup script. Like if you're using Mac, the Kafka is installed under this location, user local seller Kafka version. That's where Kafka is installed. So go to the bin folder, and you can see this all the Kafka scripts. So we're gonna need two scripts to start off Kafka and Zookeeper. Firstly, we're gonna need these command, Zookeeper server start, and the other is Kafka server start. Where's Kafka server? Yeah, these two scripts. So along with the startup script, we're still gonna need the configuration. So let's go to the config folder, and we're gonna need these two configurations when we start up the components accordingly. So let's start up Zookeeper first. So here we're gonna use Zookeeper the property to kick off Zookeeper. So let's just issue Zookeeper server start, and so let me copy the location first. All right, so Zookeeper server start and attach the configuration file, which is zookeeper.property. Hit enter. All right, so zookeeper is started right here. All right, so let me open up another terminal, another session here. So let's start. Once zookeeper is start, so we're good to start Kafka. So go to the same location, user local seller Kafka lab config. So we're gonna start Kafka, Kafka server start, and attach the configuration file, which is server.properties. All right. Once Kafka is up and running, we're good to create our first topic. All right, next, I'm going to open up another new session right here. To create Kafka topic, we'll keep the existing two sessions open so that we can monitor the log from the terminal, right? So for creating a Kafka topic is pretty straightforward. Just use the Kafka CLI command, Kafka topics, and then followed by the option bootstrap server. And here you're going to provide the IP and port where your Kafka is hosted. In this case, it's localhost. We're using default port of Kafka, which is 9092. And then followed by the option topic. And we're gonna name our first Kafka topic as ZZ Talk, and then followed by the option create. By the way, we can also define the partitions as well as the replication factor configuration in the CLI. In the command line. So here, just let's start with partitions. Let's say we're gonna create 3 partitions for this topic. So partitions set at 3, and regarding replication factors, remember as follow the best practices we discussed about in the PPT section. We better have 3 replicas per each partition, right? So in that case, let's see how it goes. So replication factor set at 3. Hit enter. Oops, we got some error right here. Well, at early stage where we play with Kafka CLI, I guess you will run into errors for different reasons. So my point is, so don't be afraid of those errors. Actually, you're gonna be highly dependent on those errors to give us some hints why those errors were thrown out. Like this example, it says error while executing topic command, replication factor 3 larger than available brokers 1. So that's a good example. That's the problem. So remember, for these demo, we only have one single host, or Zookeeper and Kafka are hosted on one single server. So basically, we only have one broker. In that case, remember, you cannot create a topic where the setting of replication factor is more than the number of broker you have. So in this specific case, we can only set replication factor as 1 instead of 3. So let's test it out by changing the number from 3 to 1. So this time it should work. Let's test it out again. Here we go. As you can see, the topic ZZ Talk was created successfully. All right. So we have more options to play with. Like if you want to list out all the uh, topics that were created, so you can use Kafka topics, Bootstrap server, localhost 1992, and then use the option called list. Here we go. So ZZ Talk, this is the only topic that was created, right? So if there are more than one, so if there's the other topic, it's gonna list right here. So let's say we got the topic name, and I want to see more detail, configuration detail about that topic. So you can do that by Kafka topics, Bootstrap server, host 992 topic ZZ Talk, and followed by the option or argument called describe. Here we go. As you can see, for this topic, we have 3 partitions, and we had replication factor set at 1. Right? That's pretty much how do we create a topic. So now let's step back a little bit and take a look at the configuration file that we use when we start up Zookeeper and Kafka. So let me jump to the folder where Kafka is hosted, which is user local seller Kafka libexec conf. Alright, so let's start with Zookeeper properties. Here we go. As you can see, we were using the default port 2181, right? And here I also create a new folder called data under this location. Basically, all the Zookeeper related logs will be stored right here. Okay, so now let me back off and take a look at the other config Zookeeper server.property. Here you can see that's where you define let's say the data retention and the default settings of partitions or replication factors. So also remember things. So if you, by the way, if you install Kafka, manually by downloading the binaries from that website. So remember, before you run that Kafka startup script, remember to add your information of Zookeeper here. Zookeeper here. Here we go, right? So you need to provide the location of your Zookeeper. So before you use this configuration to start Kafka. All right. So beside that, remember when we were creating our first topic, ZZ Talk, we defined the number of partitions we're going to use for that topic and replication factor in the command line, right? Actually, it can be done here as well. So if we did not define explicitly or in the CLI where we create a topic about how many partitions we're going to use or how many replication factors for that topic. So you're going to use that. If we didn't define in the command line, you're going to use the default settings right here in this configuration file. So let's see here. So replication. So let's try partition first. Oh, sorry, let's search partition. Here we go. num.partitions, you see the default value is 1, right? And also the replication factor, the default value is also 1, which means if I, let's say I did not create a topic with the definition of replication factor and the number of partitions defined in the command line, like what I did just now. So we're gonna use the default setting here, 1, 1. I'll show you example real quick. All right. So basically, that's the configurations of the server.conf, Kafka server.conf. All right, now we know how do we create topics, right? So we had a topic ready. So how do we produce message to that topic? So it's going to use another Kafka CLI command, which is Kafka console producer, and it's followed by the same option, bootstrap server localhost 9092, and then you're gonna put the name of the topic where you wanna produce the message to, right? In this case, it's ZZ Talk, right? And then you're gonna follow by another option called producer property. Here I'm gonna use x equal all. If you remember, we discussed about these options earlier in the PPT section. So producers can choose to receive acknowledgement of data rights. So here, basically, there are 3 options, right? X equals 0 or 1 or all. And here I chose all, x equal all. Basically, this option guarantees there will be no data loss because the producer will wait for acknowledgement from everywhere, from leaders plus every single replica. That's why it guarantees there's no data loss. Let's try it out. So hit enter. All right, so now we can produce data. So let's say, hello, welcome to the talk, and we are gonna learn Kafka together. All right, so once you're done, you just hit Control plus C to exit out. Here, it's done. I just produced 2 lines of messages to this topic. Pretty easy, huh? That's basically how do we produce data to a topic. Oh, one more thing. I promised you to show you here, like we create a topic ahead of time, right? So I promised to show you how does it look like if we did not create a topic ahead of time. Basically, we create a new topic on the go right here. So let's see what it looks like. So I'm going to use the same command right here. So instead of produce messages to these existing topics, ZZ Talk, I'm gonna give a like a name that or topic that does not exist yet. Let's say new topic. And regarding the producer's property, I'm still gonna use x equal all. Hit enter. All right, seems we can still generate, produce messages. Let's say, hello, this is a test. All right, so see here, we got some warnings. It says, new topic, leader not available, right? So, but seems we can still generate or produce messages. All right, let's exit out and take a look. So, let's try Kafka topics, and bootstrap server, localhost 9092, and list. Here we were expecting to see 2 topics right here. All right, so you can see there was new topic created called new _ topic. Let's take a look at the configuration detail about this new topic. So same thing, I'm gonna topic, new topic, and describe. Here we go. And like I said, if we did not explicitly define the number of partition and replication factor we're gonna use for these topic, and or these topic was created on the go, you're gonna use the default setting in the servers.properties file. We just review it, remember? So it was 1. Default value was 1. So that's give us another best practices to follow. So remember, always create a topic before producing message to it. That's the best practices. So of course you can modify the server's properties file. Modify the default configuration regarding partitions and replication factors. But still, so the best practices is create the topics ahead of time before producing message to avoid the issues like this and configuration error, right? So that's basically producers. And let's talk about consumers next. All right, we've produced a couple of lines of messages to the topic that we created, ZZ Talk, so far, right? So now let's move to the consumer side to review the messages that we produced. That can be done via this CLI command, Kafka console consumer, and it's also followed by the same option, bootstrap server, localhost 9092, and we want to take a look at the messages inside of the ZZ Talk topic, right? So let's hit enter to see how it goes. All right, so you noticed that so once we hit enter, it did not return anything, right? That's because, just note here, Kafka console consumer does not read all the topic. It only reads from the point when you launch it. So that's why you did not see anything, because at this point we did not produce any new topic, new messages to this topic, right? So I can verify this by cancel it out and reissue by adding a additional option called from beginning. So this way we can verify it's going to return all the messages inside of this topic. Here we go. See, these 2 lines were the ones we just produced like earlier, right? Okay, so that's how we consume the messages from a topic. To verify, I can open up a new session, and here I'm gonna issue the producer command to produce more messages so we can verify if it's able to see those new messages coming in real time, right? So let me cancel it out and remove this from beginning option and hit enter. So and switch to the other session, and let's do Kafka console producer, bootstrap server, localhost 9092, and we're gonna produce to topic ZZ Talk, and producer property, still we're gonna use x equal all. Hit enter. Alright, so now let's put more test messages that this is for testing 01. So let me copy this, hit enter. Here we go. You see on the consumer side it's showing up here, right here, right? More. Here we go. Is display all the messages we just created over here, right? That's basically what I'm talking about. It only reads from the point when we launch it. So after we launch it, we create more messages, and it's able to show it out right here, right? Let's keep moving forward. Remember when we were talking about consumers, Kafka consumer has to be part of a group, right? And here the group is the ID or name of your application. And another important characteristic of consumer group is each consumer within that group reads from exclusive partitions. So being said of that, let's create a consumer group and open up more sessions to create multiple consumers and add them all to the same group. And then I'm gonna produce some more messages to the ZZ Talk topic, and let's verify, or let's see what it looks like from each outputs. All right, so let's create a consumer group first. So for doing that, we just do Kafka consumer console consumer and bootstrap server localhost 9092, and we can take a look at the topic ZZ Talk, right? And we're gonna add another option called group. So it's like group. So we're gonna give a name of this group, same as ZZ Talk. So hit enter. All right. So it's same because we did not produce any new message yet to this topic, so it will not show anything. But right now we already create a group of a consumer group right here. Let me cancel it out right here and just issue Kafka consumer group and bootstrap server localhost 9092 list. Here we go. You see this was the consumer group that we just created, ZZ Talk, right? So looks good. Now let's move to the other side. Here, as you can see, already opened another 3 sessions. So I'm going to issue the same command to open up the consumers for each. Okay, so we're going to create 3 consumers and put all 3 consumers to this group we just created, ZZ Talk, right? So let's do that. Hit enter, hit enter, hit enter. So all 3 consumers are listening. So if now we produce some messages to these topics, ZZ Talk, we should be able to see something. And let's do that. So here, let's do Kafka console producer and bootstrap server localhost 9092 topic ZZ Talk producer property. I'm gonna do x equal all. Hit enter. All right. Now let's produce more testing messages. So let's say this is a testing message 01. So pay attention to the other side, these three consumers, and let's see how it behaves, right? Hit enter. All right, so we saw the message is showing, see, take a look at here, is the message is only displayed on one of the consumers in the group. So let's do that one more. So this is a testing message 02, hit enter. Here we go. So now this time is displayed to this consumer right here. And one more. Copy that and 03. Here we go. Now it's moved to the first consumer again right here. One more. All right, here. So because we have 3 petitions for this topic, each consumer raised messages from a different partition. So consumer group basically automatically rebalances and shares the load, if some consumers are down. So this is kind of dynamic. So let's do more. All right, so you see, this is pretty dynamic. This time, this message, the last message was showing to the second consumer right here. All right, that's basically proved my point. All right, now let's take a look at the offset. Remember, offset is like the index in the partition. Kafka uses offset to remember the location of the message it has gone through, so that next time when we reopen, it's going to continue from where it left, right? That's basically what offset for. So let's take a look at the current offset of the ZZ-Talk group that we just created. So here we go. So Kafka consumer groups and Bootstrap server, and we're going to take a look at the detail of these group that we just created, ZZ-Talk. Use the option describe. Hit enter. Here we go. So you see we had 3 consumers inside of this group, 1, 2, 3, right? And here we got 3 petitions for this topic and current offset right here. So for each partition, it shows the current offset and the login offset, and it's in sync. That's why it's showing lag equals 0 for all 3 partitions. So let's do something here. So let's Kafka consumer, let me just copy the command, consumer group and localhost group ZZ-Talk. Let's reset the offset by option reset offsets. Like there are different options. Let's see about 2 earliest and execute. To topic ZZ-Talk. Assignment can only be reset if the group ZZ-Talk is inactive, but the current state is stable. Okay, that's the narrow. Okay, good to know. So let's. That's because, see this error? This is because saying reset can only be done when the group ZZ-Talk is inactive. But right now, because I'm still these 3 consumers still active, so I need to kill it first before I can reset the offsets. So let me cancel them out by Control C. All right, now let's do that again. Same command. All right, see now new offset is 0. it was being reset to the earliest. Now let's take a look at this command, describe the group. Here we go, and you can see the difference, the lag. There are some lags for each of the partition now. So the current offset is 0 for all 3 partitions because we just reset the offsets. And for each of the partition, there are some messages being put in, right? So that's why we see this lag. So 8, 3, 5, right? So that's basically what's offset is all about. All right, the last key point I want to demo here before we call it a day is that remember when we were producing messages to a specific Kafka topic, the messages were distributed to different partitions dynamically, right? And we knew that the sequence of messages is only guaranteed at partition level, right? However, in many scenarios, we want to make sure that our data or messages are stored in the right order. So what do we do here? If you remember, we also talked about it in the PPT section earlier. So that can be done by keys. So produce with keys. If we produce messages with keys, the message with same key will always be distributed to the same partition. That's how we guarantee the order of our data. So let's verify that. So back to my console here, on the right side, I reopen the consumer group that we just canceled it out earlier. And here is listening, same consumer group, ZZ Talk, and listening to the topic, ZZ Talk, all right? And back to the main session right here. So I'm gonna produce more messages to the ZZ Talk topic. This time the difference is I'm gonna produce message with keys, and let's see what's the difference it makes, right? So here, let's do Kafka console producer and bootstrap server localhost 9092, and we're going to produce message to the same topic, ZZ Talk, right? And we're gonna producer property x equal all. Same thing, right? Now for producing message with keys, we're gonna add another 2 options or arguments, which are property. So the first one is parse.key. So basically turn to true. So basically we're gonna instruct Kafka how do we parse the keys out of our message. Basically it has to know which one we input is key and which one we input is value, right? So another one, property key dot separator. So here you can define whatever separator you like. So I'll use comma right here. All right, so hit enter. Now we can produce some messages. So I will do like ID 01, comma, and test. Just put in some random messages as value right here. So let's copy this line and hit enter. All right, so you can see the message is displaying to the first consumer right here. All right, so let's do produce more messages. Same thing. Let me copy here more. Alright, I think it's good enough. So see the difference? This time the messages with same key right here were always distributed to the same consumers, to the same partition right here, right? It did not like displaying to other consumers down below right here, because it's always being routed to the same partition, right? So now let's do something else. Let's give another ID 02, and hello. So let's create another ID or another key here to see. Enter. Same thing, it was routed to these partitions. So because it's routed to these partitions, it always go to these partition. So let's try something else. 03. Some random value here. Alright, so now you can see, because it has different ID, is the new key right here, the ID 03, right? It was routed to the other partition right here, right? Because there were different IDs, they don't have to be in the same partition. And it was routed, in this case, it routed to the third consumer right here, down below, right here. And we just keep doing the same thing. See, it was always routed to the same partition right here, down below, right? So that's basically proved my point. Let's cancel it out and reopen the producer. And let's test that out again one more time. So I'm gonna do this same. So ID 03. So here we go. See, it's still being routed to the same partition right here, right? Let's try ID 01 this time. Enter, and here it was routed to the first partition right here. All right, that's pretty much what I want to show. So in our first Kafka session. So in the following session, I'm gonna expand the scenarios further, like applying the demo. How do we create a topic via a Java application? And also I want to demo how do we build a real Kafka cluster on AWS. All right, sounds good. Cool. Stay tuned. And again, thanks for watching. So let's call it a day, and I will see you next week.
Alright, thank you for watching my video. If you think this video is helpful, you're more than welcome to leave any comments. Remember, sum up, subscribe my video, and also hit the notification bell. See you next time.